In the summer of 1997, deep beneath the surface of the Pacific Ocean, something spoke. Not in words, not in any language known to science, but in a sound so powerful, so impossibly vast, that it traveled over 3,000 miles through the crushing darkness of the abyss. Scientists at the National Oceanic and Atmospheric Administration recorded it. They analyzed it. They compared it to every known source of underwater noise. And what they found changed the way we think about what might be hiding in the deepest parts of our world. They called it the bloop. The sound lasted just over 1 minute. But in that brief window, hydrophones positioned thousands of miles apart all captured the same signal. A low-frequency rumble that rose and fell like the breath of something unimaginably large. The audio profile suggested biological origin, similar to sounds made by living creatures. But here's the problem. No known animal on Earth is large enough to produce a sound of that magnitude. Not the blue whale. Not the giant squid. Nothing in our catalogs of marine life could account for what was recorded that day. The ocean covers more than 70% of our planet's surface. Yet we have explored less than 5% of its depths. The Mariana Trench alone descends nearly 7 miles below sea level, a realm of eternal night where the pressure would crush a human body instantly. We know more about the surface of Mars than we do about the hadal zones of our own ocean. And it is in these unexplored trenches, these lightless canyons, that the bloop was born. The hydrophone array that detected the sound was originally installed during the Cold War. Its purpose was military, designed to track Soviet submarines navigating the silent corridors of the deep sea. But after the fall of the Soviet Union, scientists repurposed the network for a different kind of listening. They began monitoring the ocean for sounds we didn't understand. Whale songs, tectonic shifts, volcanic rumblings, and sometimes sounds that fit into no known category. The bloop was one of these. When the data first came in, researchers assumed it was a glitch, instrumentation error, background noise amplified by some quirk of underwater acoustics. But as they cleaned the signal and cross-referenced it with readings from other hydrophones, the reality became undeniable. This was real. This was something out there, something massive, making a sound unlike anything in the scientific record. The frequency pattern suggested muscle contraction, the kind used by animals to produce vocalizations. But the sheer scale was incomprehensible. Theories began to emerge almost immediately. Some suggested an unknown species of deep-sea creature, a relic from prehistoric times that had somehow survived undetected in the ocean's darkest corners. Others pointed to the possibility of tectonic activity, ice fractures, or underwater landslides. But none of these explanations fully accounted for the acoustic signature. The sound had characteristics of both geological and biological phenomena, as if the ocean itself were alive and calling out. The location of the bloop only deepened the mystery. It was detected in a remote area of the South Pacific, far from shipping lanes and human activity. The coordinates placed it roughly near a point known to deep-sea explorers and ocean mythologists as a region of unusual seismic and biological activity. Some even noted its proximity to a fictional location mentioned in the writings of H.P. Lovecraft, a place called R'lyeh, the sunken city where an ancient creature named Cthulhu supposedly lies dreaming. Of course, this is fiction, but the coincidence unsettled more than a few researchers. For years, the bloop remained one of the ocean's greatest enigmas. Documentaries speculated. Online forums exploded with theories. Some believed it was evidence of an undiscovered megafauna, a creature larger than any known animal. Others thought it might be a new form of geological phenomenon, something our instruments had never captured before. A few even whispered about government cover-ups, secret experiments, or encounters with something not of this world. But without further evidence, the bloop remained just that: a sound, a signal, a whisper from the deep. Then, in 2005, NOAA released an official statement. They had continued analyzing similar sounds recorded in the years following the original, Bloop, and they had reached a conclusion. The sound, they said, was most likely caused by an icequake, a massive fracturing of Antarctic ice shelves as they cracked and shifted in the frigid waters. The acoustic properties matched. The location made sense. The mystery, according to official science, was solved. But not everyone was convinced. Because here's the thing. Ice fractures do produce low-frequency sounds. But the Bloop's acoustic signature had characteristics that didn't perfectly align with known icequake recordings. The rise and fall, the almost rhythmic quality, the way it seemed to pulse, these details suggested something more complex. And even if the official explanation is correct, it raises another question. If ice can make a sound that mimics the call of a living creature, what else might be out there, hidden beneath the noise of the ocean, waiting to be heard? What if the Bloop wasn't the only signal? What if it was just the loudest? The ocean has always been a place of whispers. Sailors throughout history have spoken of strange sounds rising from the deep, mysterious drumming, eerie wails, clicks and groans that seem to come from nowhere and everywhere at once. In the age of wooden ships and open seas, these sounds were often attributed to sea monsters, to mermaids, to the wrath of angry gods. But in the modern era, we have learned that the ocean is never truly silent. It hums with life, with movement, with forces we are only beginning to understand. The hydrophone network that captured the Bloop is part of a larger system known as the Equatorial Pacific Ocean Autonomous Hydrophone Array. It consists of underwater microphones stationed across vast stretches of ocean, each one listening for sounds that travel through the water. Sound moves differently in the sea than it does in air. It travels faster, farther, bending and shifting as it passes through layers of varying temperature and salinity. A sound produced in one part of the ocean can be heard thousands of miles away, distorted by time and distance, but still recognizable. This is how the Bloop was detected simultaneously by multiple hydrophones. The sound originated somewhere in the South Pacific and radiated outward in all directions. Scientists were able to triangulate its approximate source, but pinpointing an exact location proved impossible. The ocean is too vast, too deep, too full of variables. And by the time researchers could organize any kind of expedition, the sound had long since faded into the background noise of the sea. What makes the Bloop so compelling is not just its volume, but its uniqueness. The ocean is full of sounds. Whales sing complex songs that can last for hours. Dolphins click and whistle in intricate patterns. Shrimp colonies create a crackling symphony that sounds like bacon sizzling on a stove. Earthquakes rumble. Ice groans, ships hum. But the Bloop fit none of these categories perfectly. It was something else. Something that existed in the space between the known and the unknown. In the years following the original detection, researchers began cataloging other unexplained ocean sounds. They gave them names, each one a label for something we couldn't quite explain. There was Upsweep, a long-duration sound that has been recorded continuously since 1991, its source still debated. There was Julia, a sound so loud it was detected across the entire Pacific Basin, later theorized to be an iceberg scraping across the ocean floor. And there was Slow Down, a descending frequency that remains one of the most mysterious signals ever captured. Each of these sounds tells a story, a fragment of a larger puzzle. The ocean is not a silent void. It is a living, breathing system, full of voices we are only beginning to translate. And the Bloop, for all its notoriety, is just one voice among many. But it is the one that captured the public imagination. It is the one that made people stop and wonder, what if? What if there are creatures in the deep sea that we have never seen? What if our sonar has only skimmed the surface of what lives in the Hadal zones? We know that life exists even in the most extreme environments on Earth. Hydrothermal vents, once thought to be lifeless, teem with bizarre organisms that thrive in superheated water. The Mariana Trench, the deepest point on the planet, is home to amphipods, the size of dinner plates, and fish with gelatinous bodies that can withstand pressures over 1,000 times greater than at sea level. If life can exist in these conditions, then what else might be possible? The ocean has a way of hiding things. Its darkness is absolute. Its depths are crushing. And its vastness is beyond human comprehension. A creature could live its entire existence in the deep sea and never once encounter a human being. Never once be seen by our cameras. Never once be caught in our nets. It could be there, right now, moving through the black water, and we would have no idea. The Bloop's official explanation, the icequake theory, is grounded in solid science. NOAA analyzed the sound and compared it to recordings of ice shelves fracturing in Antarctica. The match was close enough to be convincing, but the ocean is not a place of certainties. It is a place of maybes. And even the scientists who proposed the icequake theory acknowledge that they cannot be 100% certain. There is always room for doubt. Always room for the possibility that something else is going on. And that possibility is what keeps the mystery alive. Because even if the Bloop was ice, even if every strange sound we've recorded has a perfectly rational explanation, the question remains, what else is down there? What are we not hearing? What sounds are too deep, too faint, too strange for our instruments to capture? The ocean is not just a body of water. It is a frontier. And every sound we record is a clue, a breadcrumb leading us deeper into the unknown. Before we can understand the Bloop, we must first understand the ocean itself. Not the shallow coastal waters where sunlight dances and fish shimmer in schools, but the true ocean, the deep ocean, the part of the sea that exists in perpetual darkness, where light has never reached and never will. This is a world we have barely touched, a world so alien that exploring it feels less like oceanography and more like space travel. The ocean is divided into zones, each one a distinct environment with its own unique characteristics. The sunlight zone, or epipelagic zone, extends from the surface down to about 200 meters. This is where most marine life exists. This is the ocean we see in documentaries, full of color and movement. Below that is the twilight zone, or mesopelagic zone, where light begins to fade and bioluminescent creatures glow like stars in the gloom. Deeper still is the midnight zone, or bathypelagic zone, where no sunlight penetrates at all. But even the midnight zone is not the bottom. Below that lies the abyssal zone, a realm of crushing pressure and near-freezing temperatures. And below that, the hadal zone, named after Hades, the Greek underworld. This is the deepest part of the ocean, found only in trenches and deep-sea canyons. The pressure here is so intense that it would collapse a submarine like a tin can. The temperature hovers just above freezing. And yet, life persists. Strange, ghostly creatures drift through the darkness, adapted to conditions that would kill anything from the surface world in seconds. The Bloop was detected at a depth consistent with the abyssal zone, thousands of meters below the surface. At this depth, sound behaves differently. It travels through the water in channels, bending and refracting as it encounters layers of different temperatures. Scientists call this the SOFAR channel, or sound fixing and ranging channel, a natural waveguide that allows low-frequency sounds to travel across entire ocean basins with minimal loss of energy. This is how whales communicate over vast distances. And this is how the Bloop was heard so far from its source. The fact that the Bloop was so loud, so powerful, raises an important question. What kind of energy would be required to produce a sound that could travel thousands of miles through the ocean? If it was a biological source, the creature responsible would have to be enormous, far larger than any known animal. If it was geological, the event would have to be catastrophic, a tectonic shift or ice fracture of immense scale. Either way, The bloop represents something significant, something that demands explanation. In the years since the original detection, scientists have used computer models to simulate the bloop's propagation through the ocean. They have analyzed the waveform, the frequency spectrum, the amplitude decay over distance. And what they have found is consistent with a massive, sudden release of energy. The sound did not gradually build up. It appeared suddenly, peaked, and then faded. This pattern is consistent with both biological vocalizations and geological events, which makes definitive classification difficult. One of the more intriguing theories suggests that the bloop could have been produced by a very large marine animal in distress. Whales, when injured or dying, sometimes produce unusual vocalizations. These death songs are rare, but they have been recorded. If a creature far larger than a blue whale existed in the deep sea, and if it were injured or dying, it might produce a sound exactly like the bloop. Of course, there is no evidence that such a creature exists. But the absence of evidence is not the same as evidence of absence. The deep sea is full of surprises. In 2001, researchers discovered a new species of squid in the Gulf of Mexico, a creature so large and so strange that it seemed almost alien. The giant squid, once thought to be a myth, was finally photographed in its natural habitat in 2004. The colossal squid, even larger, was captured in 2007. Each of these discoveries reminded us that the ocean is not a fully catalogued environment. It is a place where new species are found regularly, where the impossible becomes reality. So the question is not whether large, unknown creatures could exist in the deep sea. The question is, how likely is it? And the answer depends on who you ask. Marine biologists tend to be skeptical. They point out that large animals require large amounts of food, and the deep sea is a nutrient-poor environment. A creature the size needed to produce the bloop would need to consume an enormous amount of prey, which would leave traces, carcasses, feeding grounds, some kind of evidence. And yet, we have found none. But skeptics also said the giant squid didn't exist. They said the coelacanth was extinct. They said life couldn't survive near hydrothermal vents. And they were wrong every time. The ocean has a way of humbling our assumptions. It has a way of revealing that what we think we know is only a fraction of what is actually true. And so the mystery of the bloop persists, not because we lack explanations, but because the ocean itself resists easy answers. The hunt for the source of the bloop led scientists into some of the most remote and inhospitable waters on Earth. South Pacific is a vast expanse of ocean, dotted with islands but largely empty. It is a place where storms rage unchecked, where waves can rise to the height of buildings, where the sheer scale of the water is overwhelming. And somewhere in this vastness, the bloop originated. But finding a precise location was nearly impossible. Triangulation, the method used to estimate the bloop source, relies on measuring the time it takes for a sound to reach different hydrophones. By comparing these arrival times, scientists can narrow down the general area where the sound was produced. But the ocean is not a static medium. Currents shift, temperatures vary, salinity changes. All of these factors affect how sound travels, introducing errors into the calculations. The best estimate placed the bloop's origin in a region roughly 1,500 miles west of the southern tip of South America. This area of the ocean is known for its depth. The seabed here plunges into trenches and abyssal plains, some of the least explored regions on the planet. It is also a seismically active zone, where tectonic plates shift and grind against one another. Underwater volcanoes dot the landscape. Hydrothermal vents spew superheated water into the freezing darkness. And icebergs, calved from the Antarctic ice shelves, drift through the currents, melting and fracturing as they go. The icequake theory gained traction because of this geography. Antarctica is not far from the bloop's estimated origin. The ice shelves there are constantly shifting, expanding in winter and fracturing in summer. When a large section of ice breaks away, it can produce a sound that travels for thousands of miles. These icequakes have been recorded before, and their acoustic signatures do resemble the bloop. But there are subtle differences. Differences that some researchers find difficult to ignore. One of the key characteristics of the bloop is its frequency profile. The sound starts at a low frequency and rises rapidly before falling again. This pattern, known as an upsweep, is common in biological vocalizations. Whales, for example, often produce sounds that rise in pitch as they call. But icequakes, while capable of producing low-frequency sounds, do not typically exhibit such a clear upsweep pattern. They tend to be more chaotic, more irregular. The bloop, by contrast, has a structured quality almost musical. This has led some researchers to propose a hybrid theory. What if the bloop was produced by a combination of factors? What if a large ice fracture disturbed a deep-sea creature, causing it to vocalize in distress? Or what if the ice itself interacted with underwater topography in a way that created a resonance effect, amplifying and shaping the sound? These ideas are speculative, but they reflect the complexity of the ocean. Nothing is ever simple. Nothing is ever just one thing. In the years since the bloop, technology has advanced significantly. New hydrophone arrays have been deployed. Autonomous underwater vehicles, equipped with sonar and cameras, now explore the deep sea in ways that were impossible in 1997. And yet, despite all of this progress, we have not detected another bloop. No similar sound has been recorded. No follow-up signal has emerged from the depths. The ocean, it seems, has gone silent. Or at least, we have stopped listening in the right places. But absence of sound does not mean absence of source. The deep sea is not a constant environment. It changes. Creatures migrate, ice shifts, tectonic plates move. Whatever produced the bloop may have been a one-time event, a unique confluence of circumstances that is unlikely to repeat. Or it may happen again, tomorrow, next year, a century from now. The ocean operates on timescales that dwarf human experience. What we perceive as silence might simply be a pause. And there is another possibility, one that researchers rarely discuss, but cannot entirely dismiss. What if the bloop was intentional? What if it was a signal, a message, a call meant to be heard? This idea strays into the realm of speculation, even fantasy. But consider this. Dolphins and whales communicate across vast distances using sound. They coordinate, they socialize, they navigate. If an unknown species exists in the deep sea, a species with intelligence, it might use sound in ways we do not yet understand. The bloop could be a greeting, a warning, a declaration. Of course, there is no evidence for this. No follow-up signals, no patterns, no structure beyond the single event. But the ocean is full of unanswered questions, and the bloop is one of the loudest. To understand why the bloop captured so much attention, we must look beyond the science and into the realm of human psychology. We are creatures drawn to mystery. We are wired to seek patterns, to find meaning in the unknown. And the ocean, with its vastness and its darkness, has always been a canvas for our deepest fears and wildest imaginations. The bloop is not just a sound. It is a symbol, a reminder that the world is still full of secrets. The timing of the bloop's discovery played a role in its cultural impact. The late 1990s was a time of rapid technological advancement. The internet was expanding, making information more accessible than ever before. People could now read about scientific discoveries in real time, share theories, debate possibilities. The bloop was one of the first ocean mysteries to spread widely online, inspiring forums, websites, and countless hours of speculation. It became a phenomenon not just because of what it was, but because of when it was discovered. Popular culture embraced the bloop almost immediately. It appeared in documentaries, podcasts, YouTube videos. It inspired novels and short stories. Artists created illustrations of what the creature that made the bloop might look like: massive, tentacled beasts, whales the size of islands, living fossils from the age of dinosaurs. These images, while fictional, tapped into something primal. The idea that the ocean might still hold monsters, real monsters, lurking in the depths. The connection to H.P. Lovecraft's work only fueled the fire. Lovecraft, a master of cosmic horror, wrote extensively about the ocean as a place of ancient, unknowable terror. His most famous creation, Cthulhu, is described as a massive, tentacled entity sleeping in the sunken city of Raya, located somewhere in the South Pacific. The coordinates of R'lyeh, as described in Lovecraft's fiction, are eerily close to the estimated origin of the bloop. This coincidence, while purely accidental, was too tantalizing for fans and conspiracy theorists to ignore. Of course, Lovecraft's stories are fiction. R'lyeh does not exist. Cthulhu is not real. But the power of myth lies not in its literal truth, but in what it represents. Lovecraft's ocean is a metaphor for the unknown, for the parts of existence that lie beyond human comprehension. And the bloop, whether it was ice or animal or something else, fits perfectly into that metaphor. It is a sound from the abyss, a voice from the dark, a reminder that we do not have all the answers. But not everyone was captivated by the mystery. Some dismissed the bloop as overhyped, a minor scientific curiosity blown out of proportion by the internet's appetite for sensationalism. They pointed to NOAA as official explanation and considered the matter closed. Ice cracked, case solved, move on. And there is validity to this perspective. Science thrives on evidence, not speculation. And the evidence, such as it is, points to a natural, non-biological source. Yet even within the scientific community, there are those who remain curious, who wonder if the official explanation is complete, who believe that the bloop, even if it was ice, raises important questions about how we monitor and understand the ocean. Because the truth is, we are only scratching the surface. The hydrophone network that detected the bloop is limited in scope. It covers only a fraction of the ocean, and even within that coverage area, it captures only a narrow range of frequencies. There could be sounds, entire symphonies of sounds, that we are simply not equipped to hear. And this brings us to a broader question. What is the purpose of exploring the unknown? Why do we care about a sound from the deep sea? Why does it matter if it was ice or animal, or something we haven't yet imagined? The answer is both simple and profound. We explore because we are curious, because the unknown excites us, because understanding our world, in all its complexity and strangeness, is one of the most fundamentally human endeavors. The bloop matters because it reminds us that there is still so much left to discover. In a world where so much has been mapped, catalogued, and explained, the ocean remains a frontier. It is one of the last places on Earth where we can still experience genuine mystery. And the bloop, for all the debate and speculation it has inspired, is a perfect example of that mystery. It is a question without a definitive answer, a puzzle with missing pieces, a whisper from the deep that we may never fully understand. And perhaps that is exactly as it should be. Not every mystery needs to be solved. Not every question needs an answer. Sometimes the mystery itself is the point. The bloop invites us to wonder, to imagine, to dream. And in a world that often feels small and familiar, that invitation is a gift. The bloop is not the only unexplained sound to emerge from the ocean. It is simply the most famous. But the deep sea is full of acoustic anomalies, strange signals that defy easy categorization. Each one is a piece of a larger puzzle, a clue to the hidden life and hidden forces that shape the underwater world. And each one, like the bloop, invites us to ask what else might be out there. One of the most persistent sounds is called upsweep. Unlike the bloop, which was a singular event, upsweep is a continuous sound that has been recorded since 1991. It consists of a series of narrowband upsweeping sounds, rising in frequency before fading away. The sound appears seasonally strongest in the spring and fall, and its source has been the subject of much debate. Some researchers believe it is produced by underwater volcanic activity. Others have suggested biological origins. But no definitive explanation has been confirmed. Then there is Julia, a sound so powerful it was detected by hydrophones across the entire Pacific Ocean. Julia occurred in March 1999 and lasted for about 15 seconds. Its acoustic signature suggested a massive impact or scraping event, and many scientists believe it was caused by an iceberg grinding against the ocean floor. But the sheer volume of the sound, its almost otherworldly quality, left some researchers wondering if there might be more to the story. Another sound, known as Slow Down, was recorded in 1997, the same year as the Bloop. It is a descending frequency sound, starting high and gradually lowering over several minutes. Like Julia, it has been tentatively attributed to ice-related activity, but the exact mechanism remains uncertain. And there are others. Train, whistle, BOing. Each one a name given to a sound that we don't fully understand. Each one a reminder that the ocean is full of voices we are only beginning to hear. What makes these sounds so fascinating is not just their mystery, but what they reveal about the ocean itself. The deep sea is not a silent void. It is an acoustic environment, rich and complex. Sound is how many marine animals navigate, communicate, and hunt. Whales sing songs that can be heard across entire ocean basins. Dolphins use echolocation to map their surroundings. Even fish produce sounds, using specialized organs to create clicks, pops, and grunts. The ocean is alive with sound, a constant symphony of life and geology and motion. But there are sounds that do not fit the known patterns, sounds that suggest phenomena we have not yet documented. And this is where the bloop becomes significant. Because even if it was ice, even if every strange sound we've recorded has a mundane explanation, the fact remains that we are still discovering basic facts about how the ocean works. We are still learning what is normal and what is not. And in that process of learning, we inevitably encounter things that challenge our understanding. The deep sea is also a place of extreme pressure, extreme cold, and extreme darkness. These conditions create an environment where life evolves in strange and unexpected ways. Creatures develop bioluminescence to communicate in the dark. They grow enormous eyes to capture the faintest glimmers of light. They slow their metabolisms to survive in nutrient-poor waters. And some, perhaps, develop the ability to produce sounds we have never heard before. Sounds that, to our instruments, seem impossible. One of the theories that has been proposed, though never widely accepted, is that the bloop and similar sounds could be produced by unknown species of deep-sea cephalopods. Giant squids, as we know, exist. Colossal squids, even larger, have been documented. But what if there are species even beyond these? What if there are squids or octopuses living in the deepest trenches that have developed specialized organs capable of producing loud, low-frequency sounds? It is speculative, certainly, but it is not impossible. Cephalopods are among the most intelligent invertebrates on Earth. They can solve puzzles, change color and texture to blend into their surroundings, and exhibit behaviors that suggest a high degree of awareness. If a cephalopod were to evolve in the deep sea, away from predators and human observation, it might develop traits we cannot yet imagine. And one of those traits could be a form of acoustic communication. The bloop, in this scenario, would not be the sound of a dying creature, but the sound of a living one, calling out into the darkness. Of course, this is just one theory among many, and without physical evidence, it remains speculation. But the beauty of the bloop is that it keeps us thinking. It keeps us questioning. It reminds us that the ocean, for all our technology and all our knowledge, is still a place of wonder. A place where the impossible might, just might, be real. The question of what lives in the deep sea has fascinated humanity for centuries. Long before sonar and hydrophones, sailors told stories of sea serpents and giant squids, of creatures so large they could pull entire ships beneath the waves. These stories were dismissed as myth, as the exaggerations of superstitious men. But as we began to explore the ocean, we discovered that some of those myths were based in truth. A giant squid, once considered a legend, turned out to be real. The oarfish, a serpentine creature that can grow over 30 feet long, explained many sea serpent sightings. And so the question becomes, what else might be real? What other creatures might exist in the deep, hidden from human eyes, living out their lives in the eternal darkness? The ocean is the largest habitat on Earth, covering more than 70% of the planet's surface. The volume of water in the ocean is so vast that it defies comprehension. And within that volume, there are ecosystems we have never seen, species we have never catalogued, interactions we have never witnessed. The deepest parts of the ocean are also the most hostile. At depths of 6 miles or more, the pressure is over 1,000 times greater than at the surface. The temperature hovers just above freezing. There is no light, no warmth, no easy source of food. And yet, life thrives. Amphipods scuttle across the seabed. Snailfish glide through the water, their translucent bodies barely visible. Microbial mats cover the rocks, feeding on chemicals seeping from the Earth's crust. Life, it seems, will find a way, no matter how extreme the conditions. But these are small creatures, adapted to survive in an environment where energy is scarce. A large creature, something big enough to produce a sound like the bloop, would require a significant amount of food. And in the deep sea, food is hard to come by. Most of the nutrients in the ocean are concentrated near the surface, where sunlight allows photosynthesis to occur. The deep sea relies on a process called marine snow, the slow drift of organic material from the upper layers down to the abyss. It is a meager supply, barely enough to sustain the creatures that live there. So how could a massive creature survive in such an environment? One possibility is that it migrates, moving between the deep sea and shallower waters to feed. Many large marine animals, including whales and sharks, follow this pattern, diving deep during the day and rising to the surface at night. If an unknown species followed a similar pattern, it could feed in nutrient-rich waters and retreat to the depths to avoid predators or human observation. We would rarely, if ever, encounter it. Another possibility is that the creature feeds on something we don't yet understand. The deep sea is full of ecosystems based on chemosynthesis, where bacteria convert chemicals like hydrogen sulfide into energy. Hydrothermal vents, discovered in the 1970s, revealed entire communities of life thriving without sunlight. Tube worms, clams, and shrimp cluster around these vents, feeding on the bacteria that process the chemicals. What if there are other, larger creatures that have adapted to feed on these ecosystems? What if the deep sea supports life in ways we have not yet imagined? The fossil record offers some intriguing hints. Millions of years ago, the ocean was home to creatures far larger than anything alive today. The megalodon, a giant shark that could grow over 60 feet long, roamed the seas until it went extinct around 3 million years ago. Or did it? The deep sea is a place where extinction is hard to confirm. If a population of megalodons, or a related species, survived in the deepest trenches, we might never know. They would live out their lives in the darkness, beyond the reach of our cameras and our nets. The coelacanth, a fish thought to have gone extinct with the dinosaurs, was rediscovered alive and well in 1938. The discovery shocked the scientific world and reminded us that the ocean is full of surprises. If a species can survive undetected for 65 million years, what else might be out there? What other so-called extinct creatures might be lurking in the depths, waiting to be found? And then there is the question of intelligence. We know that some marine animals, like dolphins and whales, are highly intelligent. They use tools, they cooperate, they communicate in complex ways. If a large, intelligent creature existed in the deep sea, it might actively avoid detection. It might recognize the sound of human technology and stay away. It might live in areas so remote, so inaccessible, that we have never thought to look. The ocean is vast, and within that vastness, there is room for secrets. The bloop, whether it was ice or animal, reminds us of all these possibilities. It reminds us that the ocean is not a solved puzzle. It is a living, changing environment, full of mysteries we have yet to uncover. And every time we listen to the deep, every time we send down a camera or a sonar probe, we take one step closer to understanding what lies beneath. But we are still so far from the full picture, still so far from knowing everything the ocean has to offer. In the decades since the bloop was first recorded, ocean exploration has advanced in remarkable ways. Autonomous underwater vehicles now dive to depths once thought unreachable. High-resolution sonar maps the ocean floor in unprecedented detail. Satellite technology tracks currents, temperatures, and even the movement of large marine animals. And yet, despite all of this progress, the deep sea remains largely unexplored. We have better maps of the surface of Mars than we do of our own ocean floor. The reason for this is simple. The ocean is difficult to explore. It is vast, dark, and unforgiving. Pressure increases by 1 atmosphere for every 10 meters of depth, meaning that even shallow dives require specialized equipment. At the depths where the bloop was detected, the pressure is so intense that only a handful of submersibles in the world can withstand it. And even those vessels can only stay down for a limited time, covering a tiny fraction of the ocean floor before they must return to the surface. Cost is another factor. Ocean exploration is expensive. Building and operating deep-sea submersibles requires millions of dollars. Funding for oceanographic research is limited, and much of it is directed toward studies with immediate practical applications. Fisheries, climate change, pollution. Pure exploration, the kind that seeks to answer fundamental questions about what lives in the deep, often takes a back seat. And so the ocean, despite its importance, remains one of the least understood environments on Earth. But there are those who are trying to change this. Organizations like the Ocean Exploration Trust and the Schmidt Ocean Institute are dedicated to mapping and exploring the deep sea. They use cutting-edge technology to document previously unknown species, discover new geological features, and expand our understanding of how the ocean works. Every expedition brings new discoveries. New species of fish, coral, crustaceans, new hydrothermal vents, new ecosystems thriving in conditions that seem impossible, and sometimes new sounds. Modern hydrophone arrays are more sophisticated than the ones that detected the bloop. They can capture a wider range of frequencies, filter out background noise, and pinpoint the location of sounds with greater accuracy. As these systems are deployed in more areas of the ocean, scientists are recording sounds that were previously undetected. Some of these sounds have clear sources. Others remain mysteries. The ocean, it seems, is never short of questions. One of the most exciting developments in recent years is the use of artificial intelligence to analyze ocean sounds. Machine learning algorithms can sift through thousands of hours of audio recordings, identifying patterns and anomalies that a human researcher might miss. These systems have already been used to catalog whale songs, track marine mammal populations, and even detect illegal fishing activity based on the sound of boat engines. In the future, they could be used to search for sounds like the bloop, identifying signals that might otherwise go unnoticed. But technology, no matter how advanced, can only take us so far. The ocean is not a laboratory. It is a wild, unpredictable environment. Storms can destroy equipment. Currents can carry instruments miles off course. Batteries die. Cameras fail. And even when everything works perfectly, the ocean is so vast that finding a specific signal A specific source is like searching for a needle in a haystack. A very large, very dark, very deep haystack. This is why the bloop remains unresolved in the minds of many. The official explanation that it was an icequake is plausible. It fits the data. It makes sense. But it is not definitive. It is not a smoking gun. And until someone can point to a specific ice fracture event, recorded at the exact time and place of the bloop, and say with certainty, this was the source, there will always be room for doubt, room for wonder, room for the possibility that something else was responsible. And perhaps that is how it should be. Science is not about having all the answers. It is about asking the right questions. It is about being willing to admit what we don't know, and then working slowly and carefully to find out. The bloop is a reminder of this process. It is a reminder that the ocean still holds secrets, that we still have so much to learn, that the unknown is not something to fear, but something to embrace. The deep sea is calling. It has always been calling. And as we continue to listen, as we continue to explore, we will uncover more of its mysteries. We will hear new sounds. We will discover new species. We will map new territories. And along the way, we will be reminded again and again that the ocean is not a conquered frontier. It is a living, breathing world, full of life and mystery and wonder. And the bloop is just one small part of that larger story. The cultural impact of the bloop extends far beyond the scientific community. It has become a symbol, a touchstone for our collective fascination with the unknown. In an age where so much of the world has been explored, explained, and cataloged, the bloop represents something rare, a genuine mystery. And people, it seems, are hungry for mysteries. The internet has played a significant role in keeping the bloop alive in the public imagination. Websites dedicated to unexplained phenomena feature the bloop prominently, often alongside other ocean mysteries like the Bermuda Triangle and ghost ships. YouTube channels create documentaries exploring every theory, from icequakes to giant squids to secret military experiments. The bloop has even inspired works of fiction, appearing in novels, video games, and films as a stand-in for the unknown dangers lurking in the deep. Part of the appeal is the sound itself. NOAA released the audio recording of the bloop to the public, and it has been shared and remixed countless times. When you listen to it, even sped up to make it audible to the human ear, there is something unsettling about it, something primal. It sounds like a voice, low and mournful, calling out from the depths. It is easy to imagine it as the cry of a creature, something massive and ancient, stirring in the darkness. And even if logic tells us it was ice, the imagination fills in the gaps. This is the power of sound. Unlike visual evidence, which can be dissected and analyzed, sound taps into something more emotional. It bypasses the rational mind and speaks directly to our instincts. And the bloop, with its eerie, rising tone, speaks to something deep within us. A fear of the unknown, a fascination with the hidden, a sense that the world is larger and stranger than we can ever fully comprehend. The connection to Lovecraft's Cthulhu mythos only amplifies this effect. Whether intentional or not, the proximity of the bloop's origin to the fictional location of Rayleigh created a narrative that resonated with fans of cosmic horror. The idea that the bloop could be the sound of Cthulhu stirring in its sleep is of course absurd, but it is also compelling. It taps into the archetype of the sleeping giant, the ancient terror that lies dormant beneath the waves, waiting to awaken. This is a story humans have been telling for thousands of years, from the Leviathan of the Bible to the Norse Midgard serpent. And while we know these are myths, there is a part of us that wonders, what if the myths are based on something real? What if ancient sailors, encountering massive creatures in the ocean, created stories to explain what they had seen? The giant squid was once a myth. The kraken was once a legend. And both turned out to be real. So when we hear a sound like the bloop, a sound that defies easy explanation, it is natural to wonder what else might be out there. What other legends might have a kernel of truth. But the bloop is also a reminder of the limits of our knowledge. We live in an age of information, where answers are just a search engine query away. We have become accustomed to knowing, to understanding, to having explanations for everything. And yet, the ocean resists us. It remains vast, deep, and full of secrets. It reminds us that there are still things we do not know, still places we have not explored, still sounds we have not explained. And that, in its own way, is a gift. Because mystery is not the absence of knowledge. It is the presence of possibility. It is the space where curiosity thrives, where imagination takes flight, where the human spirit reaches beyond the known and into the unknown. The bloop is a mystery, yes, but it is also an invitation to wonder, an invitation to explore, an invitation to never stop asking questions, no matter how strange or impossible they might seem. And as we stand on the shore, looking out at the endless expanse of the ocean, we are reminded that the world is still full of wonders, still full of secrets, still full of sounds we have yet to hear. The bloop was just one of them. One voice among many, calling out from the deep. And as long as we keep listening, as long as we keep exploring, there will always be more to discover, more to learn, more to wonder about. The story of the bloop is, in many ways, the story of the ocean itself. It is a tale of vastness and mystery, of sounds that echo through the darkness, of questions that linger long after the data has been analyzed. Whether the bloop was ice or animal, or something we have yet to imagine, it has served its purpose. It has reminded us that the world is not fully known, that there are still frontiers to explore, that the deep sea, for all our technology and all our knowledge, remains one of the great unknowns of our planet. We have come a long way since 1997, when the bloop was first recorded. We have better instruments, better models, better understanding of how sound travels through the ocean. We have mapped more of the ocean floor. We have discovered new species. We have listened to the deep and heard sounds we never knew existed. And yet, the bloop remains a symbol of what we do not yet know, a symbol of the mysteries that still await us in the depths. The ocean is not a place to be conquered. It is a place to be respected. It is a living system, full of complexity and beauty and danger. It is home to creatures we have only begun to understand. It is the source of weather patterns that shape our climate. It is the cradle of life on Earth. And it is, perhaps most importantly, a reminder that we are not separate from nature. We are part of it. And the more we learn about the ocean, the more we learn about ourselves. The bloop, whether it was the sound of ice fracturing or the call of an unknown creature, has sparked a conversation that continues to this day. It has inspired researchers to listen more carefully to the ocean. It has encouraged explorers to venture deeper into the abyss. It has captivated the imagination of millions of people around the world. And in doing so, it has fulfilled a purpose greater than any single explanation could provide. It has reminded us that the unknown is not something to fear. It is something to embrace. As we continue to explore the ocean, we will encounter more sounds like the bloop. Some will be explained quickly. Others will linger as mysteries. But each one, whether mundane or extraordinary, will teach us something new. Each one will add another piece to the puzzle of how the ocean works. And each one will remind us that we are still, in many ways, explorers, still seekers of knowledge, still driven by curiosity and wonder. The deep sea is calling just as it has always called. It speaks in the language of sound, a language we are only beginning to understand. It calls to the scientist, the explorer, the dreamer. It calls to anyone who has ever looked out at the ocean and wondered what lies beneath. And as long as there are people willing to listen, willing to explore, willing to ask questions, the ocean will continue to reveal its secrets, one sound at a time, one discovery at a time. The bloop may never be fully explained. And perhaps that is exactly as it should be, because some mysteries are not meant to be solved. They are meant to inspire, to provoke thought, to remind us that the universe is vast and strange and full of wonders we have yet to comprehend. The ocean is one of those wonders, and the bloop is its voice, echoing through the darkness, calling us to listen. So we listen, we explore, we wonder, and in the quiet moments, when the world is still and the only sound is the distant crash of waves against the shore, we remember. We remember that the ocean is alive, that it holds secrets, that somewhere, deep beneath the surface, there are sounds we have not yet heard, creatures we have not yet seen, mysteries we have not yet solved, and that is a beautiful thing. The journey does not end here. It never ends, because the ocean is infinite. Its mysteries are endless. And as long as we remain curious, as long as we remain willing to venture into the unknown, there will always be more to discover, more to learn, more to wonder about. The bloop was just the beginning, a single note in a symphony that has been playing for millions of years. And as we continue to listen, we will hear more. We will understand more. We will become part of the story. Before you drift into sleep, remember mystery is never truly lost, only waiting to be found. If you enjoyed this journey, subscribe for more relaxing ancient mysteries, and let your curiosity guide you deeper.